Forget everything you thought you knew about cosmic horror. You whisper about black holes, those cosmic devourers, but they are merely the universe's hungry mouths. What if I told you there are forces out there that don't just consume, but rip apart the very fabric of matter, scorch entire galaxies from across the void, and unleash beams of pure annihilation across intergalactic space? These aren't theoretical nightmares. They are the universe's true apex predators, hidden in plain sight, forces that could erase life faster than a thought. Are you ready to stare into the abyss of true cosmic terror? The cosmic whispers began in the late 1970s, faint, erratic signals picked up by instruments straining at the very edge of human capability. Astronomers, those tireless cosmic detectives, were baffled. These objects pulsed, yes, like the familiar rhythmic beats of neutron stars, the super-dense, rapidly spinning remnants of collapsed suns. But something was profoundly wrong. Normal pulsars spin down, their pulses slowly fading over eons. These new anomalies, however, would abruptly burst forth with an impossible, violent intensity, then inexplicably dim, only to flare again with a fury that defied all known stellar evolution. It was like listening to a cosmic clock that kept shattering and reassembling itself, each tick a burst of X-rays or gamma rays. The scientific community was gripped by a single, gnawing question. What was out there, screaming silently across the void, refusing to play by the established rules of the universe? The hunt became an obsession. Teams of brilliant minds, fueled by coffee and an insatiable hunger for cosmic truth, chased these elusive ghosts across the galactic sprawl. They built new, more sensitive telescopes, refined their theoretical models, and sifted through mountains of data, desperate to reconcile the impossible observations with the elegant, predictable laws of physics. Was it a peculiar type of binary system, a strange, exotic phase of matter within a neutron star? Every hypothesis was tested, every shred of evidence scrutinized, yet the puzzle only deepened. Pushing the boundaries of what we thought was possible for stellar objects, the frustration was palpable, a constant hum in the background of every research paper. Then the breakthrough. Not a gentle click, but a seismic shift in understanding. It was a shattering realization, born from meticulous observation and audacious theoretical leaps. The key wasn't their rotation, but their magnetic fields. These were not just neutron stars. They were magnetars, stellar remnants born with magnetic fields so impossibly strong, they made every other force in the universe look like a gentle breeze. We're talking quadrillions of Gauss, a force so immense that if a magnetar were positioned merely a quarter of the way to the moon, it wouldn't just wipe out our electronics. It would rip the iron from your very blood, distorting your body at the cellular level. Your molecular bonds would stretch, then snap, your flesh turning into a sizzling plasma as the forces that hold you together simply unravel. Imagine being caught in a cosmic blender, set not to puree, but to annihilate, where the blades are not metal, but pure, unadulterated magnetic fury. The sheer raw power of a magnetar's field is almost beyond human comprehension. It doesn't just exert a pull on magnetic materials, it fundamentally alters the properties of space itself. Light, the supposedly immutable constant, struggles to escape this magnetic maelstrom, undergoing bizarre transformations. Its polarization twists and turns, its very speed fluctuates, and in a phenomenon known as vacuum birefringence, it can even split into two separate beams as it navigates this warped reality. The quantum vacuum, seemingly empty, boils with virtual particles, fleeting pairs of matter and antimatter that flash into existence under the immense stress, only to be instantly crushed back into nothingness, like cosmic ghosts in a magnetic storm. When these colossal monsters undergo a starquake, a cataclysmic rearrangement of their superdense, stressed crust, they unleash bursts of gamma rays that can outshine entire galaxies for a mere fraction of a second. These aren't just powerful flares, they are focused detonations of pure energy, capable of stripping away the atmospheres of planets light years away, sterilizing entire star systems in an instant. The impact on any world caught in such a beam would be absolute, not just incineration, but a complete molecular disassembly. It's an invisible, silent killer, its pervasive reach extending far beyond its physical confines, a cosmic shredder waiting to tear apart anything that dares to cross its unseen path. The search continues, not just for more Magnetars, but for a deeper, more chilling understanding of the horrifying reality-bending physics that allows such impossible objects to exist, lurking as silent, magnetic assassins in the galactic dark. For decades, astronomers gazed into the deepest reaches of the universe, their instruments capturing faint, star-like points of light that defied explanation. They were too bright, too energetic, and most baffling of all, their spectral lines, the unique fingerprints of elements, were wildly, impossibly shifted towards the red end of the spectrum. These were not stars, not even entire galaxies in their familiar majestic spirals. They were something alien, something that screamed across billions of light years with a luminosity that mocked all known physics. Scientists called them quasi-stellar radio sources, or Quasars, a name born of bewilderment, an admission that they looked like stars, but absolutely weren't. The mystery gnawed at the heart of cosmology. What cosmic engine could possibly generate such unthinkable power? What ancient violent secret did these distant beacons hold? The search for the Quasars' true identity was a monumental intellectual struggle, a battle against preconceived notions of cosmic scale and power. Early theories ranged from exotic new types of stars to colliding galaxies, each hypothesis tested against the ever-growing mountain of perplexing data. The extreme redshift, initially dismissed as some unknown physical phenomenon, slowly, painstakingly, became understood as an indicator of immense distance. This was the critical revelation. If they were so far away, yet appeared so bright, their intrinsic luminosity had to be truly staggering, dwarfing even the combined output of trillions of suns. The universe, it turned out, harbored monsters far grander and more terrifying than anyone had dared to imagine. The truth, when it finally emerged, was a cosmic hammer blow to our understanding of galactic evolution. Quasars were not stars at all. They were the incandescent, ravenous hearts of nascent galaxies, powered by supermassive black holes, monsters millions, even billions, of times the mass of our sun, gorging themselves on cosmic matter at an unimaginable rate. Picture the most violent storm you can conceive, then multiply its fury by the mass of 100,000 galaxies. That's the accretion disk of a quasar, a swirling maelstrom of gas and dust, superheated to trillions of degrees as it spirals into the black hole's inescapable maw. This isn't just a whirlpool of matter. It's a cosmic furnace, a crucible where the very laws of physics bend and writhe under unimaginable pressure and temperature. The radiation unleashed from this infernal disk is a torrent of pure energy, a cosmic fire hose of X-rays, gamma rays, and every other wavelength you can imagine, blasting outward with a force that can scorch entire galaxies. We're talking about a phenomenon capable of sterilizing a sphere of space hundreds of thousands of light years across. Imagine a wave of pure, searing radiation traveling at the speed of light, ripping through the delicate molecular structures of planets, boiling away oceans, and dismantling atmospheres. Any world caught in the path of a quasar's full fury wouldn't just be incinerated. Its very atomic bonds would be shattered, its history erased in a flash of cosmic fire. But the horror deepens. Many quasars also blast out colossal, relativistic jets, narrow-focused beams of particles, accelerated to nearly the speed of light, extending millions of light years into intergalactic space. These aren't just streams of matter. They are superheated projectiles of pure destruction, carving paths of devastation through the cosmic web. If one of these jets were aimed even vaguely in our direction, it wouldn't just be a bad day. It would be the end of everything. The sheer kinetic energy, combined with the intense radiation, would scour our solar system clean, leaving behind nothing but a ghost of what once was. Quasars are not just ancient relics. They are a chilling reminder of the universe's primordial violence, a testament to the destructive power lurking at the heart of every galaxy. They are the universe's ultimate cosmic scorchers, engines of annihilation, that remind us how fragile existence truly is. If you're finding this deep dive into the universe's deadliest secrets as mind-bending as I am, smash that like button and subscribe for more journeys into the cosmic abyss. Your support fuels this mission to uncover the universe's most shocking truths. It began with a chilling, accidental discovery, a cosmic stumble in the dark. During the Cold War, a clandestine network of US satellites designed to detect secret nuclear weapons tests on Earth started picking up something far stranger, far more powerful, from deep space. These weren't the subtle gamma-ray signatures of atomic bombs. These were colossal, blinding flashes of gamma radiation, lasting mere milliseconds, but releasing more energy than our sun would in its entire 10 billion year lifetime. For years, these gamma-ray bursts, GRBs, remained an enigma, a classified secret, a cosmic whisper of impossible power. What cosmic phenomenon could possibly unleash such concentrated fury, so fleetingly, yet so utterly devastatingly? The hunt to decipher their origin became one of the greatest astronomical detective stories of our time. The initial data was sparse, ambiguous, and utterly baffling. Were they originating within our own Milky Way, or from the distant, unknown corners of the universe? The implications were staggering. If they were local, they represented an immediate, existential threat. If they were cosmological, their power had to be even more immense, a testament to an unseen, terrifying engine of destruction. Astronomers, now armed with the declassified data, embarked on a frantic mission to pinpoint the source of these cosmic gunshots. They built new orbital observatories, like the Compton Gamma Ray Observatory, then Swift and Fermi, each more sensitive than the last, racing against the clock of these ephemeral events. The challenge was immense. GRBs appeared without warning, flashed for a blink, and then vanished, leaving only a faint, lingering afterglow across the electromagnetic spectrum. It was like trying to catch a bullet in midair, then trace its trajectory back to a phantom sniper. Then came the breakthrough. In the late 1990s and early 2000s, the detection of afterglows in X-ray, optical, and radio wavelengths that allowed astronomers to finally pinpoint the host galaxies. And the truth was more terrifying than anyone had imagined. GRBs were not local, they were cosmological, originating in galaxies billions of light years away. This meant their intrinsic power was beyond anything we had ever conceived. These were the universe's ultimate gamma-ray burst, GRB sources, the death cries of the most massive stars, or the cataclysmic mergers of neutron stars and black holes. These are the universe's intergalactic snipers, pulling a cosmic trigger without warning, their focused beam of energy capable of erasing life across unimaginable distances. Imagine a star, perhaps 30 times the mass of our sun, burning through its nuclear fuel at an unsustainable rate. As its core collapses, it doesn't just go supernova. It forms a new, rapidly spinning black hole, or perhaps a pair of neutron stars collide and merge. In that fleeting moment, as the black hole spins up, or the neutron stars coalesce, it unleashes a colossal focused beam of energy, a relativistic jet, along its rotational axis. This isn't a diffuse explosion. It's a laser-like beam of gamma rays, so tightly collimated that only a tiny fraction of the universe is ever directly in its path. But for any planet, any civilization, any nascent biosphere caught in that beam, the consequences are absolute. The effect of a GRB hitting a planetary system is not just catastrophic, it's an immediate, total sterilization. The gamma rays would strip away ozone layers, expose the surface to lethal UV radiation, and trigger a cascade of chemical reactions in the atmosphere, creating toxic compounds that would poison anything left alive. The sheer energy imparted would induce a mass extinction event on a scale that dwarfs anything Earth has ever experienced. And the most terrifying aspect? GRBs are so powerful that they can sterilize a planet from intergalactic distances, even if a GRB occurs in a galaxy millions of light years away. If its beam happens to sweep across our solar system, life on Earth would be extinguished in an instant. It's a cosmic lottery, a game of chance played out across the vast emptiness, where the odds of survival are dictated by an unseen, incredibly powerful, an utterly indifferent cosmic sniper. The search for understanding these fleeting yet devastating events continues, a race to map the universe's ultimate killing zones. We've peered into the heart of cosmic terror, unmasking the universe's true apex predators. We started with Magnetars, those invisible shredders, born from stellar collapse, wielding magnetic fields so impossibly potent, they tear matter apart at the atomic level. Imagine not just a planet, but every molecule, every quantum bond in your very being, dissolving under an unseen pervasive force. Their magnetic fury twists light, boils the quantum vacuum, and in a starquake, unleashes gamma-ray bursts of pure targeted annihilation. These aren't just destructive, they are unravelers of reality, operating on a scale that makes our most powerful weapons look like child's toys. Their horror is intimate, surgical, and absolute. Then we journeyed to the dawn of time, confronting the Quasars, those ancient scorchers, the ravenous hearts of infant galaxies, powered by supermassive black holes gorging themselves with unimaginable ferocity. Their accretion disks scream forth with radiation storms capable of sterilizing entire galaxies. This isn't a localized explosion, it's a cosmic firestorm, a flood of pure energy that washes over star systems, boiling away oceans, dismantling atmospheres, and leaving behind only sterile husks. And for those unlucky enough to be caught in their relativistic jets, the end isn't just swift, it's total erasure, a fundamental dismantling by a focused beam of primordial destruction. Quasars remind us that the universe's most ancient forces are often its most devastating, a testament to the raw, untamed power that sculpted the early cosmos. Finally, we faced the gamma-ray bursts, GRBs, themselves, the universe's intergalactic snipers, accidental discoveries that revealed a cosmic truth, the focused death cries of massive stars or merging neutron stars, unleashing a concentrated beam of gamma rays so powerful it can sterilize life across intergalactic distances. Unlike the pervasive field of a magnetar or the wide area scorch of a quasar, a GRB is a precision strike, a cosmic bullet fired from billions of light years away. There's no warning, no escape. If the beam sweeps across our path, life is extinguished in an instant. It's a chilling reminder of the cosmic lottery, the razor's edge upon which all life in the universe precariously balances, constantly vulnerable to an unseen, unfeeling force. Now let's grasp the true scale of this cosmic annihilation. A magnetar tears you apart at the quantum level, but you have to be relatively close. A quasar scorches a galaxy, but only in its early active phase. A GRB, however, is the ultimate cosmic wildcard. It can happen anywhere, anytime, its beam reaching across distances that defy comprehension, delivering a death blow to life in an entire star system without ever being seen. It's the universe's most efficient, most unpredictable killer. Consider the profound implications for the search for life beyond Earth. We imagine alien civilizations thriving on distant worlds, but how many have been silently extinguished by a passing GRB? How many emerging biospheres were sterilized by a primordial quasar? The universe, in its vast indifference, is a lethal place, littered with cosmic killing zones. Our existence here, on this pale blue dot, might be less about a grand design and more about a cosmic stroke of luck, a continuous game of dodging invisible bullets and navigating fields of magnetic despair. The ongoing search for exoplanets, for biosignatures, is not just a quest for life, but a chilling census of cosmic survival, a desperate attempt to understand the odds in this vast, dangerous arena. We are, in essence, trying to map the universe's most dangerous neighborhoods, hoping to find safe havens in a cosmos that is relentlessly trying to unmake everything. It's a humbling, terrifying realization, but one that fuels our relentless curiosity. The universe is not just beautiful, it is profoundly, brutally dangerous. And our journey, our relentless search for answers, is the only shield we have against its indifferent fury. We've plunged into the abyss, confronted the cosmic monsters that shred the very fabric of existence, scorch galaxies, and snipe life from intergalactic distances. Magnetars, quasars, gamma-ray bursts, they are the universe's true face, a canvas painted with unimaginable power, and terrifying indifference. Our journey through these deadliest objects isn't just a catalog of destruction. It's a profound meditation on our place in a cosmos that is both breathtakingly beautiful and brutally hostile. We stand on a fragile precipice, our existence a fleeting whisper against the scream of the void, constantly aware of the silent, unseen forces that could erase us in an instant. Yet, in this cosmic dance of creation and annihilation, our relentless search for understanding shines brightest. It is our greatest weapon, our only hope, to gaze into the heart of these horrors, to unravel their secrets, to chart their devastating power. This is the audacious act of consciousness in an indifferent universe. It is the human spirit, defiant and curious, pushing back against the encroaching dark, refusing to yield to the terror of the unknown. We are the universe's eyes, its mind, attempting to comprehend its own terrifying majesty. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.